Hi guys, and welcome back to Max Electronics. In today's project we're going to be making a spa controller. Well, to be honest, I was going to have it as a private project and not put it on YouTube. I've designed a spa in a bathroom, and to be honest, the first part, which is the control panel itself, is already done and installed. However, I will still show you. We're going to be making the main controller. This is the circuit board that I've done a while back, and if I look at the schematic, it's actually dated, where is it? February 2023, so I've done it a while back, and I'll run you over it. Unfortunately, we're not going to be making that because it's too much effort and there's a lot of little components, but I will show you the actual video right here when it's been programmed, and as you can see, that's what it looks like when it's assembled. So I'll go over it with you in case you want to assemble it. It's not that difficult. So it's based on Atmega 328PAU as a main controller. Then we have the Max 7221 display driver with a dual 7-segment display. I chose wide. We have then a little touch controller, which is a MPR121 with a few touch buttons. We've got few LEDs, quite a few LEDs, CSP port for programming. That's the output through the Cat6 cable. So we've got 8 wires. We've got LEDs here for, they all explained here. So we've got E13, there's a few buttons, so those ones I believe E0, oh no, that's, trying to remember. So anyway, yeah, I'm pretty sure those ones are just touch sensors to increase the temperature. If I will bring you, yeah, so you can see that's where those buttons, well, not buttons, they actually just springs that go here. And as if you want to turn the display in a second, and if you want to turn the temperature up, you simply do that and then backwards. And the idea I've had from those controllers that you see on the screen, I bought one and turns out it was really crap. So what I've done, I've kept the case itself, but I chucked the controller. And for that case, I've designed that circuit board. And that's, you know, to decrease your temperature or increase your temperature. I'll explain some functions, pretty cool functions as well. Then we have the 3 buttons. One of them will start the pump, the other one will start the heater, and the other one will inject foam, delayed time as well. And there is way to delay. So for example, if you want to set the time, I believe you press and hold down the foam button. I'm pretty sure of that. And then you can choose the levels, how many mils, like 10 mils, 20 mils, and so on. It'll be displayed on the screen. You press again to exit. The pump is obviously on and off, the heater on and off as well. The heater will not come on until the pump is on, so you have to turn the pump on, and then the heater will come on, and you can adjust the temperature. If you turn the pump off, it'll turn the heater off. And another function that there was, the really cool one, is a water sensor, so it will automatically go into screen saving mode. So see, there's 3 LEDs. Obviously the orange one pump is, or blue one pump is on. Oh, no, sorry, I can't remember the colors. The red is off, I know that, so it's standby, so nothing is on except the red LED. No matter what you do, it will not respond. Once the water sensor fills up the bath, and once the water sensor gives a signal that the water is sufficient enough, it will wait for about 10 seconds, you know, just in case if the water goes up and down and plays with the sensor, and sensor goes on and off and on and off, so it doesn't trash the system. It'll, once the water level is solid for 10 seconds, then it will go into the current temperature, so it'll show the current temperature, and standby mode ready for you to operate. What else is here? Plenty of LEDs, and those LEDs literally just illumination, so they're not connected to anything. They're connected to those lines, but that's literally just to turn them on once the water level reaches. And they are surrounding here, as you can see. The LEDs here, which are this bunch, is the heater. So when you turn the heater, they will light up orange. So you'll see the second ring light up orange, letting you know that the heater is on. So is this. And what else? Pump as well. That's the foam. So foam is always white, I think, and then when you press it, it goes blue or something, and then counts down the time to dispense the certain amount of liquid, and then turns off. So that's that. That's just a power supply section. The smallest chip. Let me see if I can zoom in onto the circuit board so you have idea what I'm talking about. So this is the circuit board, and like I said, this is the button, so as you're touching it, it'll turn. What else is here? That's the touch buttons as well, so you just have the spring here and LEDs in the center. That's a power supply section. That's the output for Cat6, directly soldered on board. 2 more buttons, and the other side is that's where your max display driver sits. That's the display driver variable resistor. The atmega sits here, a couple of more caps, voltage regulator, and this is that, I don't know if camera can even focus on that, that U1 is the touch chip. It is tiny. So if I grab the normal ball pen, there it is. So you can see how tiny it is compared to the normal ball pen. That's the first part, and it's already assembled, so unfortunately I'm not going to be assembling that again, and I have no need for that. But let's go to the first, where that Cat6 cable plugs into, and that's all there is. So there is just Cat6 cable coming out, and it's going into here. So it comes in and plugs into the Cat6. So let's actually check out those circuit boards. So here they are. That's the main controller. I'll zoom out. As you can see, it does have 240, so be careful. If you don't know what you're doing, do not repeat anything in this video, just for your safety. And let me explain how that works as well. It seems very simple, but there's a few tricks here. So we've got main supply coming in through the fuse, through the TVS, well, then it goes through the transformer, which gives us 9 volts 400 milliamps. It goes to an LED here. It's an output for LED. Bridge rectifier. From there goes to the power supply section, and 12 volts out. And then we have a little voltage regulator for 3.3 volts, and that goes to the digital temperature sensor. You know, you can buy those sensors. It looks like a little metal tube with 3 wires coming out of it, and you supply 3.3 volts, and you got the digital data output for that. From that sensor, it goes straight into the pin 8 of the RJ45, and straight to that controller for temperature monitoring. Then we have the level sensor. So the level sensor is it's a capacitive sensor. I will show you once we get to the testing mode and to the bathtub. It's a round capacitive sensor, and you can stick it on the outside of the bathtub with a bit of a distance there, and once the water level reaches high up and reaches to that sensor, it actually senses the capacitance and triggers, and very decisive, very good sensor as well. So again, the plus 12 volts goes to the sensor, ground, and then we've got the sensor output, which is just on and off. It's a TTL, and goes to pin 1 and goes to the main controller. Then we have a couple of grounds here. We've got the heater trigger and pump trigger. So that's the outputs to trigger the heater and the pump. So let's go with the simple one. Let's go with the pump. Where is it? And there's a foam one as well. So the pump, where are you? Pump, there it is. So it goes through the 100 ohm resistor and a little MOSFET transistor, and then it goes to the mode switch. So the mode switch, what it does, it uses the ground, and it uses common as the pump output. So then when you, as a ground, so when you doing some service on a spa, for example, it's a 3-position switch, so it's off in the center and nothing will trigger it. Even if you press the buttons, it'll light up that it's on, but nothing will come on. So then you got manual, which flips and shorts those two, and that just shorts it directly to ground, triggering the pump running, without turning anything else on. And you go to auto, and that will actually let the pump run only with the controller. Let's go with the foam now. So foam is very simple as well. It's just the foam triggering the MDT 6N15, which triggers a relay, and the relay just goes to 240 and triggers is actually 240 there, the dispenser. And the heater one is a tricky one because there's a few safety and redundancies. So then from here, once it's triggered by the panel, by the controller, it goes through that optocoupler. The optocoupler will trigger when the pump is on. So if pump is on, the signal will not go further. Anyway, let's say pump is on, it goes through optocoupler, and then it goes through the relay. And relay has to be on, and is triggered by the water heater level sensor. So what that is, it's actually just a rod that is generally in all the spa water heaters that sticks out as next to the heating element, and it's connected to here. And it responds to ground, so if there is no water in the actual heating chamber, it will not ground. That's connection 0, and therefore it will not trigger the relay. So once the water is shorting out between ground and that pin, it will trigger the relay. So in case there is no water or pump's not priming or something, it will not trigger the heater, avoid the meltdown. Anyway, let's say there's water in the chamber and it triggers that relay, then it goes through further, and there is a physical thermal cutout switch. The water heater itself is does have one by default, but this one is anyway just an extra one. And usually what I do with this thermal cutout, because there's enough safeties already, I usually put a thermostat, an old school thermostat, the one that's got a little tube and it's mechanical, and you set it to maximum temperature, let's say 42 degrees or something, so it can't go further than 42. If something goes wrong, if say the controller freezes, the relay breaks down, I don't know, the whole thing just breaks, you still got a last thermal cutout that it will heat up to 42, and then that thermostat will click off, and then it goes to the heating relay. So that's the connector that will connect to the relays, which is pump relay and the heat relay. Well, the heat is more like a contactor, so is the pump. But here we go, and that's the board. So let's assemble it now, and then we'll go and test it out. So here we go. So there it is, fully assembled, and now before we're going to test it, there's a few more steps to do. I want to apply the silicon to all the high voltage areas just to isolate it. I did lacquer it, as you can see. In case you're curious, the lacquer I'm using is this stuff, which is a protective circuit board lacquer by Serviceall. It's a local Australian one. I don't know, probably you can use any lacquer that is electrical. So this way it will protect it from any moisture, you know, since it's going to be used in the bathroom, even though there's not going to be any moisture in the environment of that circuit board. It's still better be safe. So the only things that are exposed pretty much the connectors. Even sprayed it under the transformer, and I will put the silicon around that. Where is it, by the way? Oh, there it is. I bought this Chinese stuff. It's actually pretty good. K705. That's the one that I always use for circuit boards and stuff like that. So before we do all that, let's have a quick word from our sponsor, PCBWay, who is proudly providing those amazing PCBs. This video is sponsored by PCBWay. PCBWay is the leading manufacturer of high-quality multi-layer circuit boards with unbeatable prices. Simply upload the zip file with your project directly to the website, select your preferences, preview your board, select the postage, and get an instant quote. Now you're just one click away from getting your project completed. PCBWay also offers a range of services such as PCB assembly, CNC milling, 3D printing, sheet metal fabrication, and injection molding. Your project will be manufactured by highly trained professionals with a state-of-the-art equipment and delivered to you in no time with safely packed and vacuum-sealed packaging. Prototype the easy way with PCBWay. Quality, integrity, reliability. So I've got everything ready. We've got the voltage here. Well, it's not connected yet, but it will be, so we'll go live. And neutral. I'm not connecting ground because ground is really needed just for the water sensing, which I'm going to short out just between here. We'll put it on now, and the sense. So we've also got a couple of jumpers for the thermal cutout, which we can put in now because it doesn't really matter. And the other one we'll try with a common and with an auto and manual switch. I've got a little jumper here for the enable. So again, that just shorts out the enable pin and the 12 volts, which will go in a second. But let's plug it in now. So this is going to be live, so got to be careful. I'm going to put it through the thermal, through the current limiting just at first, just in case it blows up. So here we go. Alright, so that's on. Should be good so far. Let's enable the level and see if that will light up. Yep, I can already see the green LED. Now, let's try the pump on manual, which would be this jumper. Yep, the pump is on, as you can see. Let's try auto. Well, we'll put it in auto because we want to leave it in auto. The next step is we're gonna use the cable that I've done with 3 pins, which is going to be the blue one is pump, the red one I think it is the heater, or some one way or another. So we'll plug that in, and I've got a 1K resistor from 12 volts just to short it as to simulate the MCU signal. So let's go for pump first and see if that will turn on. Yep, pump's working, as you can see. Let's try the foam relay, which is this one, the orange. I don't know if you can hear it clicking. I can hear it clicking. And let's go for heater, but for the heater, if we short it out, I don't think it will turn on until we will short this to that. That enables it. Still no heat, and that's because the pump is not running. So now we're going to enable the pump. And what else am I missing then? Still no heat. What am I missing? So heating is not coming on, and I don't know why. I'm gonna have to pause the video and trace it out, because right now the heat should be on. That's the pump. And there is no heating, just the pump. Levels on, that's shorted. Alright, I'm gonna quickly trace it out and see where the signal stops and what my mistake is. And then I'll explain what happened. Excuse the previous video, I've just realized that I forgot to press record on the audio recorder, and so the sound you were hearing is actually coming from the camera, not from the mic. Anyway, not making that mistake again, but I figured out what was wrong. So I've accidentally put the optocoupler other way around, and that's why I was doing this. There was no heat. And then after that I thought I'll test it off camera just to make sure. The optocoupler was dead, by the way. Obviously I've put 12 volts through the LED, and this way and the actual LED was solidly on. Even if I pull, say, the earthing or anything, it just was on, and I couldn't figure out what was wrong until I pulled this pin, or turns out the relay was faulty, was stuck closed, so replaced the relay as well. Let's try it out again. The power is coming on now, so we've got the enable is only digital, so even if I pull it out, it still should be working, because the enable is only processed by the Atmega. Alright, let's do the pump again. So pump should come on, no problem. Yep, there it is. And the heat will not come on if I short it out to heat. There we go. Nothing. Pump is working though. So if I connect them together, which is heat and pump, again nothing is on because we got missing the pin, which is the heater water level. So if there's priming, so if there's no water in the heater, it will turn on. However, if I short circuit that, the heater is on. So another protection is the let me find the tweezers, thermal cutout. So if that gets pulled, if I can get it out of there, I need something to grab it with. If I pull this, obviously the heater stops. That's the thermal cutout. And what's the other one? So obviously we've got temperature sensor. If the let's leave it in this configuration. I'll show you another one. So this is the one that's supposed to go through the water. I'm going to just quickly add it to the metal rod here, and I'm going to hold it in my hand so the heater is on. And just to show you how sensitive it is, so I'm holding, that's a ground, and if I touch that pin, so current's going through me, again it's such a low voltage, I can just turn it on by touching. The finger is not even wet, so I'm just touching it and you can see the heater is on. That, so that's the sensing for the water level in the heater. What's the other protection? So again, if we turn the pump off, so I'll disconnect that and separate those. So that's the pump, and if I disconnect that and just turn the heater on, that's not going to come on, and that's that. So again, that's the relay for the foam, which will be outputting 240, and that's it. So I'm just gonna respray all the stuff that I've desoldered and resoldered, and after that I'm gonna apply some silicone. We'll see how that cured, and then we'll install it into the spine and see how it operates. So we're in the bathroom at the moment. It's still getting renovated, so there's still a few things to do, like a shower screen, and anyway, so excuse the echo. That's the controller, by the way, right here. We'll see it in operation soon. I thought I will show you before we install the card the contactor box, which is located just down here. So you'll see on the right, the far right, is the heater contactor. Then there is a heater relay to activate the contactor, which is converting from 12 to 240. So then we have the black relay right here in the center, which is interlock relay, which means the heater relay can't work without the pump. Then we've got just a few connectors for the mains input, and we've got a contactor for the pump, but that's going to get replaced with a soft starter, which is going to be a lot more better. Instead of just slamming the pump on, it's going to slowly start. That green thing right here that you can see is the water sensor level. So that's what's sensing when there's a water in the bathtub. And we've got a few things that I will show you. So I'm going to put that together. Here's the box with the indicators, and then we'll get back to the circuit board, which I've already plotted in here, and see how that operates. So that's been installed, as you can see. All is assembled. That's the control module, so it's off at the moment. There is no power. So let's flip the circuit breaker on. So we can see the power lights on, and there's a red light on here indicating. So I'm going to put a little bit of water into the pump, and then we'll run it by manual. So that should fill the tubes a little bit at least. And let's run the pump by hand, so that would be manual. Yep, we're good. So now let's try to see if we can enable the sensor. So there's a light, I don't know if it should be visible from here. So I'm going to put my hand over that sensor there, but on the other side, on the bathtub. And that should enable, there we go, the green light. And that should enable this within 10 seconds. And we'll see if the temperature is showing okay. So that's powered on, but we've got no reading on the screen. Oh yeah, there we go, 24 degrees. Just took a little bit to boot. So that's working fine. So if I remove my hand now from down here, it will turn off. The reason it takes a delay is because the water, you know, it can fluctuate, go up and down, and you don't want it trashing the system, going on, off, on, off. So once the water is stabilized, it's triggering the enable. But I'm going to start filling the bathtub, and then we'll test it all out. I think there's enough water there now, and we can see the panels on. Let me just turn the water off. So we've got 36 degrees and the level showing that green light, so it's enabled obviously because the panel's on. So let's turn it on. Shall we do it manually? Let's do manual first. So let's go manual. That works fine. Let's go to auto mode. And now we can control it with this. Add a bit of foam. I think that looks pretty good. I'm going to put that panel on and I'm gonna hop in there and enjoy it. So this is it for Max Electronics video about the Spark controller. I hope you enjoyed it. Don't forget to like, share and subscribe. All the files to manufacture the project is going to be free below in the link. I hope you enjoyed this. See you next time. My name is Max. Bye.